Chapter 30, Air Brake Foundation Systems and Air Brake Circuits. Day 1, Video 5, Air Compressors. So we've talked about, we are using compressed air to power the system. So we have to have a air compressor that performs that duty for us. On the over-the-road trucks, we use it's driven from the engine off of the gear train on the front of the engine. So in an attachment to the engine through some flanges and some brackets and stuff, we've got the air compressor being driven off of the gear train of the engine. So when the engine is running, the air compressor is turning also. We use the engine's cooling and lubrication system to cool and lubricate the air compressor. Just like we would a small engine, it has to have certain needs there for the cooling and the lubrication. So we just tie into the engine system. It's got plenty of capacity to handle that air compressor. Different configurations. By far the most common is the two-cylinder reciprocating piston style. The reason why we have different size and configurations of the air compressor is due to the duty cycle, the use when we compressing air to when we're not compressing air dictates the size of that compressor so that it can handle the output of the system. And then we've got additional air systems. If we were having multiple brake wheel ends, that would affect the compressor sizing also. So looking at the compressor, we've got just cylinder head, crankshaft, crankcase like we would an engine. We use cast iron to make the air compressor out of. And then we load and unload the air compressor. And what that means is we are turning the air compressor on or turning it off when we've reached our goal for the pressure in the system. Couple of the aspects here: when we compress air, that air becomes hot, so it increases the temperature of the air. One of the things that we'll do is to use annealed copper or sometimes a steel braided hose that comes from the compressor down to the air dryer. The reason that we do that is the compressor is mounted on the engine, so we have vibrations from the engine, movement of the engines. It's mounted through the engine mounts, so that allows the engine to vibrate and move a little bit, while the rest of the system is bolted onto the frame that does not vibrate and move. So we need to have a way of connecting those compressors to the rest of the system and compensate for that movement. The annealed copper, the reason why we use annealed copper is it does not work harden. So all those vibrations and the engine moving back and forth would not cause that copper to get hardened and crack and then cause an air leak. And then it uses, just like the engine, we lubricate the cylinder walls of the compressor. So looking here on the left, we've got a couple of single cylinder air compressors, and then more on the right here is the dual cylinder air compressors. So lots of different manufacturers. The ways that they configure them can be different there too. So the basic concepts of the air compressor, if we look at this from the cylinder from the pistons and on down, very, very common between this and an internal combustion engine. Pistons, cylinder, connecting rod, bearings, crankshaft. We use lubricate the systems in here, so pistons and piston rings, to trap the air in there and compress it. We start getting a little bit of the difference here is in our cylinder head. That's where we've got some different poppets and springs and all that sort of stuff in there. A air compressor does not have a valve train. It's got poppet valves, and they're spring-loaded valves that the air is drawn around and through, and they close off and on. So a little bit different from a internal combustion engine there.